So our project today is about cooling a vehicle without having to use the engine. So what we realized is when you park your vehicle in a parking lot, what happens is the sunlight actually heats the interior cabin to a very uncomfortable temperature. I mean, everyone's experienced it. And you return to your car and you basically don't want to get in. We have elderly users saying that it's too hot and they feel that it's difficult to breathe. So what we want to do is somehow cool the car passively or actively while it's parked and when you're not in the vehicle. And some of the current solutions in market, what people do is they put a sunshade on to sort of block the IR radiation from coming in from the windshield, but the problem with that is it's a real hassle to have to come out and open up the sunshade and put it in every single time. I mean, I have a sunshade for my vehicle, but I don't put it on purely because it takes too long to set up. In addition, there's other solutions, some called desiccant cooling, where some people put materials that absorb moisture, such as rice, inside the interior vehicle. Again, not very feasible because you don't really want to be lugging around rice all around your vehicle at all times. In addition, we have a reflective paint, which is paint that actually reflects off heat. And what it does is it does a really good job of controlling the temperature of the exterior of the vehicle, but not so much of the interior cabin, which is where the users are actually seated. And finally, there are solar-powered fans, and they're actually being marketed and they've been around for many years. What they are is they're solar-powered fans that basically increase air circulation within the cabin. The 1993 Mazda 929 had it as a luxury feature. It cost a couple $1,000s. Audi remarketed in 2000 with the A6, and then in the 2010, the Toyota Prius is going to have a huge solar panel on the roof of the vehicle, and it's going to power our entire system, which is pictured here, of moving air through the car from the ambient temperature. Again, what they're doing is people realize that it's really a green shift now, and that's the buzzword. People want to use green technologies, and the interior of the vehicle is a problem, so they're trying to use the green shift to market this old product that doesn't really work, whereas we can come up with a solution that works better and is both green. So if we go over here to my colleagues, Katrina and Mike, we'll show what our solutions are. So essentially we approached two companies with solutions, and we were looking at first electrochromic glass. What it is it's a piece of glass with a thin film on one side, and you can actually control the tint of how much light gets let through by applying a voltage on two electrodes that's connected to the glass. So if we open up the box here, you can see that it's at full tint mode, and if we tilt the box slightly, you can see that the visible light transmission through isn't very hot. And what we can do is if we hit a control button at the back, we can make the tint less. Now, because this is electrochromic glass, it takes about 2 to 3 minutes for the state change to fully change. So we're going to leave this for now, and then we'll tilt back and show you. You can see that it's getting brighter already. The second box is our control box. So this is essentially what's in your vehicle right now. It's a purely transparent glass, and if you can see, it's very bright. And finally, we have a product by E-Time Energy. They're a company out of China that's brand new. They're coming into the North American market. And what they do is a nanotechnology film, which resists about 85% of IR radiation into the cabin of buildings, because they're focusing on buildings right now. We approached them with an automotive application, and they're excited about it. They block 85% of IR radiation. And as you can see, it's a bit dimmer than our control board, because this glass is tinted at about 13%, which means it's allowing 87% of visible light through. Now this tint is variable, so you can actually apply it to your car at whatever tint level you want. So highway traffic access, you need approximately about 60-70% of light transmittance. So if you wanted to go for a darker tint feel, you could go for about 20% tint. And what we've done is we've actually run these experiments. This is our prototype. It's essentially a hot box. We have a floodlight that you see that's heating through a piece of glass in an enclosed chamber with the top. And we've been running this for about half an hour, and you can see through these temperature sensors the actual difference. So our electrochromic glass, it started at a temperature of 23.6 degrees Celsius, and right now, through half an hour, it's increased to 27.7. Whereas our control glass, which is what's in your vehicle right now, has increased to 39.3 degrees Celsius. So we're talking about 10 degrees within half an hour by using this electrochromic glass. Finally, our e-paint solution has increased to 34.5. While its performance isn't as good as the electrochromic glass solution, its price point is a lot more reasonable at this point. In order to line your vehicle fully with e-paint, it costs about the same amount as tinting, Whereas if you wanted to completely retrofit your vehicle with electrochromic windows, the current in-market prices are about $7,000. Now, we expect this to go down. Now, we have research that says from 2005 that says within the next 5 years, we're expecting electrochromic glass to drop in price for about 50%. And what we really need is, if we wanted to adopt the electrochromic glass solution, it adds an extra feature set that allows people to variably tint their windows. So perhaps someone is in the back seat wanting to sleep. They can actually adjust. If I'll just step out of frame here, they can actually adjust through their window. This is a mock-up interface that we've done. If they press this button, they can variably tint their specific window so the light doesn't transmit through it. So everyone has their own variable tinting solution, and the driver has a complete control over all 4 windows and a lockout button. In addition, because our basic scenario is to prevent heat from going in, every time you lock your vehicle with the heat fob, it will trigger the mechanism to darken the glass so that heat will not enter while you're exiting the vehicle, while the vehicle's parked. So essentially, you can see both solutions work. Right now, if you wanted a quick solution, it would probably be e-paint just because of the price point. But if you're looking down the road in 5 to 7 years, if we can get sort of the automotive application for electrochromic glass in, we'll see the price point fall to a reasonable level, and it'll be a new feature that we hope will be standard in most vehicles because it is a problem area. Thanks. So I'll show one last thing. So it's been about 2 minutes, and you can see that the electrochromic glass is completely clear. Great. Thank you for your time.